We are a Singapore-based startup. We started, I don't think we're a startup anymore, but we started as a startup in 2016, so it's been a long time. We've spent the last 7 years working on free space optics, trying to build a new generation of the technology that addresses two very important problems that we've seen in the industry. One is reliability. One of the main reasons we think the major telecom companies have still not adopted free space optics as a key solution is that they require 4 to 5 nines reliability, carrier reliability. And that's not a simple thing to provide when it comes to free space optics, pointing micro radian laser beams across kilometers and expecting them to work at those kind of reliability. So that was the first problem that we looked at. And the second problem is the price point. It's been proven in singular projects for the last few years where people can make highly reliable laser communication links, but they're extremely expensive. So how can we bring the price point down to a point where the cost per bit is at a scale that makes it commercially competitive to what currently exists in the millimeter wave and microwave environment? So these are the two things that we've been looking at for the last 6, 7 years. And the outcome of all of that work is the CENTAURI. So the CENTAURI is our flagship product. It is a point-to-point laser communication device that can send up to 25 gigabits per second, up to distances of 3 kilometers. Why 3 kilometers? That was by design and by choice, because we believe that the biggest challenges that currently exist and the strength of free space optics is in areas which have really high spectrum congestion. And that's basically in urban environments where the radio frequencies have already been highly used. There's a lot of congestion going on. And in these environments, the distances between the cell towers needs to get closer and closer to each other. That's why we designed a product that we thought would work effectively up to 3 kilometers and will still have enough margin to fulfill the requirements of what the telco providers need. The product that we built is one of the smallest in size. It's the size of a shoebox. It's around 20 by 15 by 30 centimeters in size. It's around this big. And it weighs less than 3 kilograms. It uses just up to around 20 watts of power as well. So it's very small. It's very lightweight. And we can provide up to 5 nines reliability at those distances. Obviously, you have to take the rain zone in mind. You have to take things like fog into account as well. But when deployed within the parameters that we specify and with our recommendations, we have been able to provide reliable 5-9 availability to a lot of carriers that we're working with. We can also provide nanosecond latencies, internal latencies inside the device. And that's because the product that we're building is a purely layer 1 product. And for that reason, there's very little internal latency that we have. So this is a product that we've been building for the last 6, 7 years, and I'm very proud to say that it's been deployed in all five continents, and we've delivered hundreds of these devices to some of the world's biggest telco companies. And I can just show you some photos of some photos of the device in action. So here you can see some simple screenshots of our deployment toolkit, aligning laser beams with micro radian precisions of kilometers apart from each other is not an easy thing to do. So we built a fully automated browser-based tool where anyone, I would dare say a primary school kid who knows how to click on a laptop can basically deploy these links within around 20 minutes from one side to the other side. Once you have the system, you look through something like a video, like you can see in the photo here. You point your device toward your target. As long as you're within around 4 degrees of your intended target, you press a button, and then everything is automatic from then onwards. And we've been deploying these devices all around the world in various kinds of weather conditions. We've been in typhoons in the Philippines. We've been in Korea. We're in North America in various cities all around Southeast Asia and Africa. So we've been testing the product in all kinds of weather conditions, all kinds of temperatures, and working with a lot of majority of the telco companies in these areas. And the main use cases that we're looking at are backhaul and fronthaul applications. So in a lot of these areas, people want to basically expand their 4G cell towers in areas where it's too expensive to set up new fiber optic cables. There's not enough spectrum available, or there's simple right-of-way issues. And so that's when we come in and we deploy our Centauris. And it's been a really exciting journey, and we're hoping we can finally crack the telco market.